Okay, so 5.1, classifying triangles. We're going to start off with just like parts of a triangle. So it says, what is the symbol for a triangle? We just have this little symbol here. So if you see a triangle symbol, that means triangle. How would you name a triangle? You actually use the symbol and then use the points of the triangle. So this would be W, X, Y. And when you name a polygon, whether it's a triangle or square or whatever, you would name these in order, like around the shape. It doesn't matter whether it's clockwise or counterclockwise, but it should be in order. Then the sides of a triangle, we have 3 segments. So you'd have segment WX, segment XY, and WY. And then vertices. What that word means, if you don't recall, it means the corners. So the corners here would be point W, point X, and point Y. And then angles would be the angle right here, angle X, W, Y. That would be that angle. Then this angle would be angle W, X, Y. And then this angle would be angle X, Y, W. When you name an angle, the middle point has to be the vertex of that angle. Okay, so triangles can be classified in two ways. These words should be pretty familiar to you. They are classified by their angles or by their sides. All triangles have at least 2 acute angles, but the third angle is used to classify the triangle. So for example, down here we have the classification by the angles. So these are just to classify it by the angles. Acute triangle is when all the angles are acute. All angles are acute. And how this might look might be like this. And all those angles are less than 90 degrees. Equiangular, and that's how you say it. Triangle is when all the angles are the same measure. So it would look like this, and then all the angles would be the same measure. And as you may remember, the angles of a triangle add up to 180. So in this case, if all the angles were the same, 180 divided by 3 would be 60 degrees. So in an equiangular triangle, all of these would be 60 degrees. Okay, and obtuse triangle. An obtuse triangle actually has 2 acute angles and 1 obtuse angle. So if it has 1 obtuse angle, then it's an obtuse triangle. And the reason why it only needs 1 is because if it had more than 1, the lines wouldn't connect. So this right here is an obtuse angle. And again, if you look at it, there are 2 acute angles, but as long as it has 1 obtuse angle, it's obtuse. And then we have right triangle, and that would be if it has 1 90-degree angle. And you should be pretty familiar with that. $90-degree angle. And notice that it does have 2 acute angles as well, but we're just using that 190-degree angle to classify it. Okay, then up at the top here it says, note a triangle will always have 2 acute angles, like I mentioned, and then the third one is what we use to classify it. And then triangles can also be classified according to the number of congruent angles or sides that they have. So here, equilateral triangle. Equilateral means all sides are the same measure. So all sides are congruent. What happens here, though, is since all the sides are congruent, the angles are also congruent. So if a triangle is equilateral, it's also equiangular. And if a triangle is equiangular, it's also equilateral. Then for an isosceles triangle might look like this. It has two sides that are congruent. So two sides are congruent. And that's isosceles. Do you remember that from whatever math? Maybe elementary school? It's been a while though. With an isosceles triangle, like these two sides that are equal, the angle opposite those two sides, so maybe look up here for a second. What I mean by the angle opposite that, so this side right here, the angle opposite that would be this angle, and the angle opposite this side would be this one. The angles opposite those two congruent sides are equal as well. So just to note, and that comes up in a later chapter, but just pointing that out now. So if the two sides are equal, then you also have two congruent angles as well. Then a scalene triangle is when all sides are different lengths. All sides different lengths. So in this triangle I drew, let's say this is like 2, maybe a length of 5 and 7. They're all different lengths. It's a scalene triangle. Okay, then we are going to do some examples. It says classify the triangles by, we're going to classify it by angles and sides. So here, it has one obtuse angle right there. So therefore this is an obtuse triangle. And then by its sides, it looks like all of the sides are different lengths, so this would also be a scalene triangle. And then for B, we have two sides the same length, so I'm automatically thinking isosceles. Also, I have this 90-degree angle. What's that? It froze. Oh no, what did you say? It froze. Okay, hopefully it'll stay. Okay, so I have a 90-degree angle, so that means it's a right triangle. And then two sides the same length, so isosceles triangle as well. And then C, all the angles are the same, all the sides are the same length, so this would be equiangular. And equilateral. Okay, number 2, then it starts bringing in the math. Find the measure of the sides of isosceles triangle ABC. Okay, shows the isosceles triangle. With this is equal to this length, so we can set these expressions equal and solve for x. So 4x plus 1 equals 5x minus 0.5, and then just solving for x. I get x equals 1.5. It doesn't ask for x though, it wants the measure of the sides. So once I get this, I can plug it into these expressions. Oh wait, that would be 6 plus 1. 6 plus 1 is 7. So the length of this side is 7. And since it's isosceles, this would also be a length of 7. And then for this side, I would have to plug it in again. 9 times 1.5 minus 1. And I've already solved it out. It's 12.5. Okay, and number 3, solve for x and find the length of each side. says triangle FGH is equilateral. That's an important piece of information. And then it gives us the length of each side, but in an expression. So with equilateral, all the sides would be the same length. So we could choose any two of those and just set them equal and solve for x. So FG would be x plus 5 equals 3x minus 9. And now I'm going to solve for x. Why do I keep writing the wrong thing? I don't know. Okay, x equals 7. And then to find the length of each side, I can choose any one of these because they're all the same and just plug it in. So FG is x plus 5, so 7 plus 5, which FG would be 12. So therefore, everything will be 12. And you could check it if you wanted to, but why? There's one more type of question I want to go over because it shows up on the homework. The other type of question that you might find with this is, let me zoom out, is what if they gave you, why am I keep coughing? Okay, so they give you 3 points, and I'm just putting 3 random points on here. They give you 3 points, and they say, okay, is this triangle scalene, isosceles, or equilateral? And so what you would do is just like sketch out your triangle and then determine that on your own. So you might have to find the length to decide. But in terms of like whether it's scalene, isosceles, or equilateral, we can see it's not equilateral. Maybe we're not sure if it's scalene or isosceles, but if you sketch out those right triangles, this right triangle would be 1 by 1, 2, 3, 4, 5, 6, 8, 1 by 8, and this over here, 7 by 1, 2, 3, 4, 5, 6. When I use Pythagorean theorem, I can already tell it's going to be scalene. Some of the questions go one step further and ask for side length. And again, just do what you've already learned. Just 6 squared plus 7 squared equals c squared. You'd get 36 plus 49. And just continue solving. And then the answers are in square root format. So 36 plus 49. So it would just be like 80 square root of 85. Or this one over here, you do 1 squared plus 8 squared equals c squared. You get square root of 65. And then you're looking for these in the answer choices. So if you get one like that, that's what it's looking for. We are going to cover one more lesson though. Hold on. Okay, moving on to the next page, 5.2.